Hi, this is a video for Math 2-3, Unit 3, Coordinate Geometry. This is Part 2, using the slope of a line segment. Finding slope should be a very familiar activity, but we're going to use it for finding some information about shapes in this section. Here's the rectangle that we're working with, at least we think it's a rectangle. We haven't proven that yet, with the vertices A, B, C, and D. So this is quadrilateral, A, B, C, D. And we're going to look at the slopes of the horizontal line here, this vertical side here, and the diagonals. So the slope of AB, slope is always found by finding the difference in the y values divided by the difference in the x values. That symbol right there that just looks like a triangle, that is the Greek letter delta, and it stands for the difference. The slope formula can also be expressed like this: y2 minus y1 divided by x2 minus x1. One of the most common mistakes in working with slopes is to reverse these, put the x's on the tops and the y's on the bottom. You just can't do it. The answer is simply wrong when you do that. One way that people remember this is by using the mnemonic rise over run. Which gives us the rise is usually the up direction, and run is usually the left and right direction. If a line has negative slope, then the rise, of course, is going to be in the downward direction, but it hopefully will help you remember the idea. In this case, we are looking for the slope of AB. So on the top, we've got the y values, and on the bottom, we've got the x values. First thing you should notice is that 9 minus 9 is just 0. And 10 minus 2 is 8. That fraction reduces to 0, showing us that this horizontal line, and in fact any horizontal line, including this one down here, should have a slope of 0. The slope of BC, the vertical line here on the side, is going to be done in a similar manner. It's the difference in the y values over the difference in the x values. Let me just show you another common mistake here. On the top, we're going to use y2 minus y1 in the numerator of the fraction, and on the bottom, it's really important to keep the points in the same order. If I use point B as point 1 and point C as point 2, then I have to do the subtractions in the right order. Otherwise, the slope of the line will be the opposite from what it's supposed to be. So we have to do x2 minus x1. Again, if you get that backwards, it's simply wrong. There's no excuse, because you should be able to look at the diagram and check to see if the line you're working with has a positive or a negative slope. So this comes out to be, we're going to do on the top, negative 6 minus 9, and on the bottom, 10 minus 10. First thing you should notice is that 10 minus 10 is going to equal 0. Doesn't really matter what we have on top, but negative 6 minus 9 comes out to be negative 15. There's a problem with this. The problem is that you can't divide by 0. Nowhere in our number system is dividing by 0 allowed. However, there's a little bit of a workaround for this, because obviously this line here exists. This line is perpendicular, or meets at a right angle, to the line horizontal here that has a slope of 0. If we think of the idea of 0 being nothing, then the opposite of 0 has to be everything. In other words, we can look at the slope of that line as being infinite, and that gives us a workaround so that we can work with it. We'll show why that's important very soon. If you calculate this on a calculator, you are going to get a slope that it's just called undefined. The next one to look at is AC, the diagonal line that goes from A to C. You should recognize right off that that is a negative slope. So when we do our calculations, if we don't come up with a negative number, we've done something wrong, but we will. Again, we're looking at y2 minus y1 over x2 minus x1. And I'm going to pick the lower right-hand point, C, to be y2. And so A is y1. So I'm going to do the difference in the y values, which is negative 6 minus 9. That should be familiar from the slope that we did before. We've already seen that combination of numbers. And on the bottom, the difference of the x's is 10 over 2. And we've already seen that before also. So this comes out to be negative 15 over 8, which of course is the same as the fraction negative 15/8. Both versions of that are correct and are equivalent. And we should see that since this is a negative, this line has negative slope, that makes perfect sense. And there's nothing that we can, these have no common factor, so we can't reduce it. So, are they right angles? Specifically, I'm looking at the horizontal line AB and the vertical line BC. We know that those are, one is horizontal and one is vertical, so they really should be meet at a right angle. In other words, they are perpendicular, just like the x and the y axis are, but we've got something that's interesting here. The slope of AB, that equaled 0, and the slope of BC, that was undefined or infinite. To meet at right angles, two lines have to be what we call negative reciprocals. Negative reciprocals. Two big words, but negative just means that the signs are opposite. One is positive, one is negative. And reciprocals means that they are flip-flopped fractions. So for example, 0 over 1 flip-flops. The numerator becomes the denominator. 1 over 0. This, 0 over 1, that's equivalent to 0. And this over here, 1 over 0, is undefined. But we're saying that for intents and purposes of this problem, its slope is infinite. It goes straight up and down, in other words. So since neither 0 nor infinity has a sign, we can't say anything about their signs being negatives of each other. So are they negative reciprocals? You have to stretch your imagination a little bit for it, but this special case was worth highlighting. So if you come out with two lines whose slopes are 0 and 1 over 0, or 0 and infinity, or 0 and undefined on the calculator, we do say that those are perpendicular. In other words, they meet at a right angle. So another line here in the last part of this is the line BD. It does not look like they meet at a right angle, but we can't assume that. We have to check it. So the slope of BD, y2 minus y1 over x2 minus x1. Same formula, again, using point D as point 2. We get the difference in the y's is negative 6 minus 9, a familiar quantity there. But look at D and B. Now the x and the y coordinates are backwards from what we had before. So we've got 2 minus 10, which is a negative. That's important to see the difference there. If you mix up the order, you will get a negative slope, and this line clearly has positive slope. So that's the sanity check, the way to check your work on this. So this gives us negative 15 divided by negative 8, which a negative divided by a negative is a positive. So that's the same slope, just with a different sign as the line that intersects at the other diagonal. Applies. Do the diagonals meet at a right angle? Well, if they meet at a right angle, they have to be opposite signs. One is the negative of the other. But they also have to be reciprocals, which means that the fractions are flip-flopped, top to bottom. Are they negative of each other? Yes. We've got negative 15/8 and 15/8. Are they reciprocals? No. Careful not to mix those up. So do the diagonals meet at a right angle? The answer is no. And that's the end of this video. Part 3 will have to do with the next concept, which is the midpoints of lines.